Assalamualaikum warahmatullahi wabarakatuh, and hi everyone, especially to my panels. It is an honor for me today to deliver a presentation of my Bachelor Degree Project 1. First of all, let me introduce myself. My name is Nadhirah Binti Ishak, and I am supervised by Technologist Dr. Rashid bin Nuri. My title of this project is Real-Time Water Quality Monitoring using IoT near Saltwater area in Sungai Melaka. Before we go further explanation, these are the contents of my presentation that cover 4 chapters of my project, which is Introductions, Literature Review, Methodology, and Preliminary Results. First, I would like to explain my introduction of this project. For the background of study, Melaka is a state located in the southern part of Malaysia, which has been always the focus of tourists from around the world because it is a historic city recognized by UNESCO on 7 July 2008. The rapid development in the state of Melaka has contributed many advantages and disadvantages to the locals. Among the effects that can be seen are the advantages through wider employment opportunities, business development, investment, and more. However, a development can also bring adverse effects to the state of Malacca, which cause environmental pollution. The problem statement of this project are modernization and industrial growth. This is obvious through the improvement in water quality that have occurred because of the modernization efforts that are currently being conducted without of any limitation or obstruction. As seen in figure, the river water becomes more blackish, polluted, and release an unpleasant smell. As we know, the Malacca River is a popular tourist destination, thus this scenario quite terrible to present to tourists. In addition, industrial growth, growing population as well as uncontrolled land use produce large amount of silt in river also lead to water pollution. Such activities cause soil erosion to water. As a result, there is an increase in material mixing, higher turbidity level, and issues with river sedimentation. Environmental and ecological systems may be harmed because of the pollution that being created, as well as human health. The presence of dead fish was one of the many conflicts issues brought about by this environmental situation. Due to the low level of dissolved oxygen in Malacca River, several examples of hundreds of wild marine and freshwater fish floating and dead in the river has been recorded. There are 3 objectives that need to be achieved in this project, which is to develop devices on the casing and electronic parts. Second, to monitor the saltwater quality at Malacca River. And last but not least, to analyze the data collection result according to the measured parameters. Next, the scope of this research are: this study is to focus on monitoring the water quality of the Malacca River in terms of parameters such as pH, turbidity, temperature, total dissolved solid, and dissolved oxygen. Second, this study will be implemented using low-cost devices integrated with the Internet of Things (IoT) to facilitate remote monitoring the parameter by user. Third, the study covers near saltwater area in the estuary of Malacca River. Fourth, the study aims to monitor water pollution that occurs in the Malacca River and the deterioration of water quality. Last, this study aims to observe changes in water quality in the Malacca River within a specific period of time. Let's move to the second chapter, Literature Review. What is water pollution? According to previous research, water pollution also occurs when organic and inorganic compounds as well as biological compounds accumulate to hazardous amount and contaminated water. For the past research method, the traditional method is a technique of evaluating water quality is to collect sample of water by manually and submit them to a laboratory for testing and analysis. For Internet of Things, is a system of Wi-Fi modules sends data gathered by sensors to the microcontroller and then to the smartphone or PC. type of parameter. According to Vibude, in general, a pH value of less than 5 indicates acidic, value between 5 and 6 indicate neutral, value from 6 to 7 indicate alkaline, and value from 7 to 8 indicate basic. While according to Ziad Asami, dissolved oxygen's level are a result of wind and aeration. To sustain the stability of organisms and fish live in bodies of water, the DO level must be kept within a specific range. The greater the DO, the better the aquatic and aquatic survivability circumstance. For the total dissolved solid, according to Puja, the total dissolved solid value is used to determine the concentration of minerals, salts, metals, cations, and anion in water. For turbidity, according to Ramadan, its turbidity is referred to the degree to which water loses in clarity as a result of suspended particle. The greater the particle concentration, it has the greater the turbidity. Last but not least, the temperature according to the Ramadan is the metabolism of an aquatic system is regulated by the temperature. A sensor is a transduction device that detects events or changes in its surroundings and then produces an electrical output in response. Precision, resolution, linearity, and speed are the most significant features of a sensor. Water Quality Index. According to Puja 2020, WQI is a grading system that includes a single term to evaluate the entire quality of water. It plays a role in the selection of an appropriate treatment strategy for the condition at hand. A river's quality has a significant impact on people's life. Because of urbanization and modernization, river water pollution has become a severe concern in Malaysia, affecting the quality of water sources. The Department of the Environment (DOE) has categorized the Water Quality Index into 5 categories: Class 1, 2, 3, 4, and 5, according to the National Water Quality Standard (NWQS). Now, I will present my third chapter, Methodology. Next is about the research area. The study will be conducted at the estuary of the Melaka River to monitor the quality of salt water in the river and will collaborate with the Perbadanan Pembangunan Sungai dan Pantai Melaka (PPSPM). This low-cost device that has been developed, HydroQS, will be placed on the surface of the river water to facilitate the process of taking parameter data to be monitored. Next, I will explain about the flowchart of this project. The flowchart shows the process start at identify problem statement, objective, and also scope of research. I also did study previous research by doing literature review. After having methodology planning and structure work process, I continue my project with print all the mechanical components using SLS machine. Then, the next step is assembling electronic components and housing. This step might face some challenge and difficulties. If any damage happen or fitting session does not success, this process need to be repeat the 3D printing again. If there is no problem occurred, it may proceed to the system configuration. Subsequently, I did some pretest of system that consists of sensor reading, calibration, and also IoT. It is important to ensure that all sensors have been installed, work well, and were able to record the reading of each parameter. I would like to draw the attention that this semester my work process only able to complete it till pre-test of system. For the field test will be conducted next semester in my study area at near Saltwater area in Melaka River, or to be specific, estuary Melaka River. By right after the field test is completed, all the data that has been collected by HydroQS that can be monitored through the apps developed, I will analyze the data obtained. In addition, I will also analyze the condition of the HydroQS component from time to time after being placed in water for a specific period. The analysis will take into consideration any structural changes such as decay or corrosion that may occur. Last but not least, all of this project work process and study will be documented for further development. The following part is Hydro Quality System, HydroQS. HydroQS is a low-cost device that works to monitor river water quality. The device also integrates IoT as the latest technology capable of transferring data over the network with easy interaction. HydroQS consists of three main components involved: casing components, sensor components, and also electric components. For casing components, it have main body, buoy assembly, solar panel casing, and also camera housing. While for sensor component, it has pH sensor, dissolved oxygen sensor, total dissolved solid TDS sensor, turbidity sensor, and temperature sensor. Electric component consists of Arduino Uno, power bank, and also solar panel. Now I will explain about the sintering process. For pre-processing stage, there are 4 steps which are measuring the weight of the material based calculation on height defined by Farson SLS software, Farson All-Star TM Open platform interface with 400 mm x 400 mm x 450 mm feeder chamber size. The weight required for the FS3200PA powder to fill up is about 60 kg powder. Then, the powder will be put into the mixer machine to make sure that the powder blend well before being collected and sent to feeder chamber inside the SLS machine. The second stage is printing or sintering process, where the parts being sintered using 70 watts CO2 laser. Once the sintering process complete, at post-processing stage A, the build chamber being drew out from the sintering machine, and then the part together with the powder cake being pushed out by the actuator below the build chamber towards the acrylic casing as shown in the figure A. B, the powder cake then being moved to powder cleaning machine as to remove all the non-sintered powder before being recycled again for the next sintering session. C, all the components that need still have a huge powder cake attached to the body will be removed by using tools such as brush. D, apart of using handy tools, sun-blasting pressure also can remove excessive powder cake that remains at the components and ensure it cleaner than before. Now it's time me to present about the HydroQS structure design. The main body of the HydroQS, which consists of a camera housing component that holds a smart home camera that is capable of motorized pan and tilt 360-degree visual coverage and protects from water splashes, while all parameter sensors, power bank, and Arduino Uno are housed in the casing of the sensor. Next is buoy assembly. It shows the assembly of a float section using 6 pieces of PVC pipe as the main float component, which is connected via a connector that has been printed via 3D printing and glued using epoxy, then coated with silicone for waterproof function. The buoy frame is connected to the main body using aluminum rods that have a solar panel casing and solar panels on it. Beside, it has a casing of sensor. This figure shows the bottom of the casing of sensor that houses all the parameter sensor to be monitored. There are 5 special spaces to place the sensor and 1 empty space for setup if there is an addition of sensor in future research plan. We have reached the last chapter, which is the preliminary test. Let's move to the result and discussion. Based on this figure, it indicates the pH sensor can detect the pH value of the calibration liquid used. This sensor can produce acid reading in the range 1 until 6, while for neutral in the range 7 until 8, and alkali it shows a value from 9 until 15. Other than that, we also observe the dissolved oxygen. This figure shows reading of 0.2 mg per liter recorded by the dissolved oxygen DO sensor. This is because when the pretest is carried out, the liquid being tested is not channeled to any sources of oxygen. While this table shows the value of total dissolved solid TDS in unit of part per million ppm, the higher the value recorded, the less the quality of the water. For turbidity, this shows the turbidity value of the water that have been tested. Turbidity can be accessed physically through the color of the liquid, while according to the recorded value, a high value means the more turbid the liquid. For temperature, during the pre-test session, this figure records the temperature detector functioning well and being tested in air-conditioned room. As the conclusion for this project, it has been proven that HydroQS can monitor water quality in the Melaka River estuary covering saltwater areas. The implementation of IoT in this project is very helpful in the observation of the collected data. All monitored parameter data such as pH, temperature, turbidity, total dissolved solid, and dissolved solid record a normal reading. That's all from me. Thank you for your time.